Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 244. Please turn to it. Page number 244, and today is our lesson number 349. This problem that you see there on problem number 244, problem number 6 on page 244, is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solution, you will find the original solution on day number 141, where we have done this problem at a slower pace. Here we're going to go a little bit faster. Here's what we're looking at. We are given a quadratic equation here with the second power. It's a quadratic equation, and there are two ways we can go about solving it. One is to simply use the quadratic formula. The second method is what is known as factorization, which is what we're going to do here. Instead of using the quadratic formula, we'll try to find its factors. If you're not familiar with the concept of factorization, or if you feel that you need more help on this concept, I have listed here all the videos that you can see, that you can watch, that will help you get better familiarized with the concept. Day number 338, 312, 313, 314, 315, day number 141, 142, 124, 129, and finally day 99, 100, 101, 102, 103. There's plenty of material here for you to work on. So here's how the factorization method goes. We're looking for two factors. We're looking for two numbers. What kind of two numbers are we looking for? Well, these two numbers that we're looking for have to possess two characteristics. One is that we're looking for two numbers such that when we multiply these two numbers, we have to get a product of positive 1 times negative 14. Where are these two numbers coming from? Positive 1 times negative 14. These are the coefficient of x squared and the constant here. Here it's just an x squared, which means it is positive 1. So the product has to be positive 1 right here times a negative 14. This positive 1 right here and a negative 14. And the second characteristic that these numbers have to possess is that not only they have to multiply to be negative 14, because if that was the only condition that their product has to be negative 14, then we're looking at one pair right now. 1 and negative 14 will give us a product of negative 14. But they also have to add up to, when we add them, we have to get positive 15. Positive 1 and negative 14, when we add them, we get negative 13. We don't get positive 15. So can you think of two such numbers? Pause the video if you have to for a few seconds. Put your thinking cap on and see if you can think of two numbers such that when we multiply them, we get a negative 14. When we add them, we get a positive 5. As I said, pause the video if you have to for a few seconds and think of two numbers. The two numbers that we're looking for are, here it is, 14. We can break up 14 as positive 7 and a negative 2. What we find is that positive 7 times a negative 2 gives us negative 14, and positive 7 plus a negative 2 is going to give us positive 5. You see, we're looking for a sum of 5 and a product of 14. So we found our two numbers, 7 and negative 2. Let's see what we can do here. So now we're going to write this midterm. The term that appears in the middle is called the midterm. These are called terms. It has three terms in it. We're going to write this 5x as 7x minus 2x. And watch what happens. We're going to write that as 7x minus 2x, because 7x minus 2x is 5x. So we have x squared plus 7x minus 2x equals negative 14. And now we start looking for the terms that are common, the factors that are common in the first two terms. This term and this term, where do we find a common factor? X squared and the 7x has a factor of x common. Let's take it out, and this becomes x plus 7, because x times x is going to give us x squared, and x times 7 is going to give us our 7x. We're done with that part. Now look at this term and this term. A negative 2 and a negative 14. Is there anything common between a negative 2 and a negative 14? Of course, negative 2 is common, because we can divide negative 2 evenly by negative 2. and we can divide negative 14 evenly into negative 2. Negative 14 divided by negative 2 is going to give us 7, which is what we see here. So let's take out 2 common, and we end up here, out of this part we just end up with x, because negative 2 times x is going to give us negative 2x, and here we end up with positive 7. Again, because negative 2 times positive 7 is going to give us negative 14. Let's erase this part, this is too crowded. That's it. Now we look at this part and this part. Is there anything common between these two terms? This term and that term, is there anything common? The answer is yes. The common part is this part, x plus 7. Let's take it out common. X plus 7 equals, x plus 7 is taken out. And once we take out x plus 7, what are we left out of this part here? We are left with only x. As you see 7 plus x, x plus 7 times x is going to give us x times x plus 7 minus a 2. Because again, x plus 7 and minus a 2 is going to give us this part, negative 2 times x plus 7. That's it, we're done, and the whole thing has to equal 0. This thing has to equal 0. So now we have two quantities, and we are told that their product is 0. If the product of two quantities is 0, that's only possible if either x plus 7 is equal to 0 or x minus 2 is equal to 0. Of course, there is a third possibility that both of these quantities might be 0, which is just as well. If x plus 7 is equal to 0, that implies that x is equal to negative 7. On the other hand, if x minus 2 is equal to 0, that implies that x has to be positive 2. There we go. We found our two roots. These are called roots. The roots of these equations, are negative 7 and a positive 2. Now what we're going to do is, we're just going to take a few extra seconds and we're going to make sure our answer is correct. We're going to make sure that our answers are correct, our roots are correct, by plugging them back in the equation and see if they work. Shall we? Let's do it. Let's do it up here. Or can we do it? Let's do it right here. We have no other choice. Or we can do it right here. First one says x squared plus 5x minus 14. When we plug in negative 7 for x here, we better get a 0. So x is equal to negative 7, so we get negative 7 squared 5 times negative 7, negative 14. Negative 7 squared, negative 7 times negative 7 is just positive 49. 5 times a negative 7 is going to give us negative 35 minus 14. And what do we find? We find that negative 35 and a negative 14 is in fact 49. So 49 minus a negative 49 is going to give us 0. It works. This solution is correct. Let's see if this solution works. X squared plus 5x minus 14. If x is equal to 2, we get 2 squared plus 5 times 2 minus 14. 2 squared is just 4 plus 5 times 2 is 10 minus 14. And what do we know? 4 plus 10 is 14. 14 minus 14 is 0. That one also works. Both of these solutions, both of those roots are correct. Tomorrow we'll do part F, the last part, which is also a quadratic equation. But as you will see tomorrow, the next one actually is a little bit tricky one. Why don't you try that yourself first? See if you can find factors. Part 6F is what I'm talking about. I'm giving you a homework. Do the next part. Look at the next equation, which is x squared minus x minus 1 equals 0. And see if you can factorize it. See if you can find its factors, just like we did here. Alright? I'll see you tomorrow. Bye now.